Okay, math teamers, here's a video for the second category in the math meet, number 4, log and log equations. So let me review some log rules for you. Log base a of b equals c can be rewritten as a to the c equals b. A and b must be positive. Also, if you have this, you can rewrite it like this. So for example, log base 3 9 equals x is saying, what does x have to be for 3 of x to equal 9? That's why x is 2. Over here, x squared equals 5, so x could be 5. The base can never be negative. 2 to the 6 equals x, so x is 64. So here's 3 different places to put x and the 3 different values of x. A reminder on exponents. 3 to the 4th is 3 times 3 times 3 times 3, 81. 3 to the 3rd, 27. Notice I'm dropping it down by 1 every time. 3 squared, 9. It's dividing by 3. Dividing by 3. And if you divide 3 by 3, you get 1. So 3 to the 0, anything to the 0 power is 1. And from 3 to the negative 1, when it's a negative, sometimes people think it's a negative value, but it's not. It's a reciprocal. It's 1 over 3 to the first power. So you get 1 over 3. And if it's 3 to the negative 2, it's 1 over 3 squared. So that's where I get 1/9. Okay, I don't know if you can see this. A to the b over c is the same as valuing a to the b and then 1 over c. I actually use this more often. I usually take that base to the 1 over c power and reduce it and then raise it to the b power. So like if I have 8 to the 2/3, I would take 8 to the 1/3 power first because I know 8 is same as 2 cubed. And then you'd have 2 cubed to the 1/3 power. Power to a power, you would end up canceling, so these would wipe out to be just 1. So I know this is 2. And then I'd have 2 squared. So I would have tackled it this way. That's the way mine, because you can't use a calculator, right, in this category, so you might as well break it down if you can first. The 1/2 power is the square root, the 1/3 power is the cube root, etc., etc. Also, rules for logs. If you're adding 2 with the same base, then you can just multiply. If you're subtracting 2 with the same base, it's a division. If you have it to a power, log of a to a power of t, you can put it out front as t times log of a. Likewise, or the opposite, if you have t log of a, you can write that as a single log a to the t. There's a lot of problems, I think, in the 3-point category that say, write it as a single log. So knowing that this becomes this is pretty helpful. And then you could, and I'm not sure how often it would show up as helpful without a calculator, but log base a of b is the same value as log of b divided by log of a. Sometimes that shows up when you're multiplying logs together and you can cancel out numerators, denominators, and numerators. Always check your final answers as a and b must be positive. All right, let's try some out. Expressing this in simplest form. These have the same base. So I know I can write it as a division problem. Log, whoops, gotta learn how to spell log. Log of 8 over 32 plus log base 3, oh sorry, there's supposed to be a 3 here. Log base 3 of 16, which means I'm going to multiply. So if you don't mind, well, 8 over 32 is 1/4, and then 1/4 times 16 is 4. So this is the same as log base 3 of 4, because I had to divide those, and then I multiplied it times 16. Simplify this. Log of that times log of that times log of that. Holy smokes. I think this one, because there's different different logs, I'm going to tackle it like this. Log 625. If you don't mind, I'm not going to write log every time. Let me stop writing log. But I know it's a log of 625 divided by the log of 9. And this is the log of 1 over 243. You know what would be better than all this is writing it in terms of its base. Like 625 is 5 to the 1, 2, 3, 4. And 9 is 3 squared. In this log, in the denominator I have 4, which is 2 squared. In the numerator I have log of 1 over 243. So that's negative. And 243 is 3 to the 5th power. So I'm going to write 3 to the negative 5. Again, this is log, 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 so I don't know if this is going to work out. Log of 8 would be log of 2 to the 3rd over log of 125, which is 5 to the 3rd. Now these things don't just cancel, because this is really the log of 5 over 4. And I could go divided by the log of 5 to the 3rd. Log of 5 to the 4th divided by log of 5 to the 3rd would be just log of 5. No, it wouldn't. Log of, I should have practiced my log rules. Log base 5 of 4 divided by log base 5 of 3 is just 5, because it's another power of 5. So that's 5. Log of 3 squared in the denominator, but log, so what you want to do is subtract, right? 4 minus 3 is 5 to the 1. Negative 5 minus 2 is 3 to the negative 7. And 3 minus 2 is 1. 5 times 2 is 10, divided by 3 to the 7th power. Holy smokes, that's a huge number. That's a weird, well, no wonder it was a 4-point problem. I think I did that right. I don't have the answer key handy, and I'm just going to keep the video going. Sorry. Find x if log, okay, notice 243, 27, 243 is showing up again. That's 3. That's 3 to the 5th power. So this is like log of 3 to the 3rd power over log of 243, which is 3 to the 5th power. So because we have, like before, 3 minus 5. 3 minus 5 is negative 2. What's 3 to the negative 2? 1/9. There's your answer. For this one, we need to write this as a single log first. After we write it as a single log, we can bring in this 2 part. So because it's a subtraction, I need to divide. Oh boy, 4-point problem. Let's see, maybe I can do this. Log of x plus 5 over x minus 2. And this is to the base of 8. And that still equals 2. So now that I have it as a single log, I can rewrite it. 8 squared equals this mess. 8 squared is 64, so if you don't mind, 64 equals x plus 5 over x minus 2. Now I have a proportion. You can go 64 times x minus 2 and get, let's change color so you can follow along. 64 times x minus 2 is 64x. Minus 2 times 64 is 128. And that equals, I didn't leave myself enough room. That times that equals x plus 5. So now I'm going to solve this for x. This is not going to come out very pretty. Subtract x from both sides and get 63x equals, I'm going to add 128 to both sides and get 133. Then I'm going to divide by 63. And I don't think this, 7, oh it does, 7 goes into this. I was going to say this is the answer, but you can divide these both by 7. 7 goes into 63, 7 goes into 133, 19 times, and 7 goes into 63 9 times. So there's the final answer. Because if you put 133 over 63, you wouldn't get credit. You got to have it reduced. Solve the following for x. They don't have a base, so that means they all have a base of 10. These two are two logs that are added, so I'm going to multiply. So log base 10 of 6 times x plus 5 equals log of 96. Well, since log of this equals log of that, that means this equals that. So I don't need to have the log anymore. I can just say 6 times x plus 5 equals 96. Divide both sides by 6 and get x plus 5 equals, divided by 6, and I get 16. Then subtract 5. Final answer is 11. X equals 11. And no, nothing there, so that's the end of this video. Have a great day.